חד. כן.
למה אם הוא מחובר לכבל היחיד ששם, הוא מחובר למסך?
זה תשאל אותם, אני... חד. רגע. חד, אוקיי. חד. בסדר.
אני יכול להעיף את המסך, הוא כזה חוסם אותי כל...
אוקיי, נראה לי שהצלחתי לסדר את זה. צריך לבדוק על איזשהו מכשיר. כנס שנייה ל... אוקיי, אז לא משנה, אתה תתעסק בלחבר את זה, אני אעשה למישהו אחר QA. גוד, אוקיי, זה עובד. בואו נראה פה, פרזנט.
אני מרגיש מינימום ישראל, שאני מסדר לאנשים את ה-DH.
Congratulations, מה אני עושה עם זה? זה ג'סטרס. זה חזק. אני צריך להוסיף את זה לטוב. זה ריקוד.
אני, רבה.
או, מה העניינים?
לא זה גזורת.
ברוך השם.
לוקח את זמן שזה כאילו... בוא, שני.
רשום לך שם. איזה אור אתה רוצה לכבות? עכשיו עשיתי את היופי. עוד? לא, נראה לי בסדר, לא? ויש לך את הפס, אבל לא נראה לי יש ביחד לפס בדיוק מעליו.
עכשיו הכל סגור חוץ מזה.
לא, זה לא. לא, מה הייתי תדליק?
האחד, שניים בודד.
ככה זה טוב?
לא, עוד אחד.
לא, למה? ככה זה סבבה.
ככה זה טוב, לא.
לא, למה? זה היה טוב את הסגור.
תקליק על מה שהרגע...
אבל יחשיך עוד מעט.
אבל היא רוצה...
לא, אין מתגים פה.
ככה.
לא יודע. How was playing the...
Careful not to spoil our appetite. There's a lot more pizza in there.
I ate 5.
Only 5?
Only 5.
מייקי, תחליט מה שאמרת. את ההצעה שלך.
איזה גם?
קיבלתי כאילו...
מעולה. יופי, כל הכבוד.
עכשיו הבא זה...
וואו.
שכזה, אני אקרא לכולם להתחיל לשבת?
כן.
שני?
זהו, אני אגיד לך מה הבעיה שלך. אתה תמיד חושב שהעצות שאני נותן, אבל לא חוטף.
או. למה הוא לא מזהה לי פה את הזה? את המעבר של הסליידס?
כשאני לא מחדד זה לא חוטף.
מייק עשית מינגלינג?
מה?
עשית מינגלינג?
כן, בטח.
אוקיי.
טוב, נדבר כזה, נדבר ונקרא.
כן.
סבבה. יאללה, בזה.
המצלמה
הכל
מזכירה
בסדר,
אותך?
ב-20 עובד, נכון?
כן, יש לי פה אבל בעיה אחרת.
בשביל להזמין את המכונה הזו? תדע את זה כבר?
כן, את לא צריכה את הדבר הזה, תוכל לקרוא את זה.
לא, אבל...
תעשה עם האצבע,
מבקש
תעשה את הטביע לאצבע שלך.
כן.
חשבתי שהוא מבקש ממני.
כן, אבל את יכולה לעשות עם האצבע. מחליף את ה...
האמת שאני לא רואה מה זה.
ראיתם שהם שמו את הלוגו של אלומה ב...
וואי, זה כבוד המיג'וד?
כן. או
לכתוב המרץ של אלומה?
או שאתה קונה. תלוי איך אתה...
אנחנו כיוונו לגוגל עם הדאבל אור והצבעים.
יש מצב שהם היו
קצת
לשם.
כיוונו לשם.
מה שמת פה?
חשבתי for onboarding.
או, מה קורה? ברוך השם.
אחרי זה שואו שמתי לשם
לא, לא. אני רק פה בשביל ה... כן. לא אינווידיה, עוד...
צריך, זה עושה ריוויו, הוא נותן לזה משהו, פשוט עושה אישור וזהו.
אוקיי. נעשה ככה.
כתבת שאתה צריך machine for training? כתבת? מה?
אז זה onboarding plus dev.
כל החדרי שיגוע. ידידו מעבדות אלקטרוניקה, אחי. כל מקום מבריגים. בחדר אחד על אחד? וואלה, אחי, חצי מהחדר זה פלזמה. כזה שיש שם וידאו קונפרנס.
מה זה טוב?
מה, שתשב כאילו מול מישהו ותדבר איתו? הכל עובד לך?
אתה רואה שהם
כן, כן.
ראית את זה?
ראית
כן.
שהם שמו טלוויזיה עם סטנד, אני לא הבנתי, עמוד שחור.
אותו דבר?
מה זה שרק מטורף? מה זה הדבר הזה?
אז אותו דבר יש בחדר one on one, שתבין כאילו זה 50% מהחדר זה תופס.
מגזימים.
כאילו אתה יושב בזה ומבוכה, יש פלזמה ענקית. זה הקסמה.
ולראות סרט אחי ולהרגיש בפנים.
ממש.
זה
חבל שזה לא מחובר לשם, זה חוץ מאשר על הוידאו.
חבר את זה לנטפליקס.
טוב, אתם יושבים פה?
תשתדל. אני מאוד אשתדל, כי אני יודע שזה לא כזה קל. בסדר ככה? כן. אשתדל לזוז כמה שפחות. אוקיי. עושה מאמץ. תגיד, מה המקום האידיאלי לחבר הזה? קודם כל מתחת לחולצה. אוקיי. אבל אחרי שנייה... כאילו תדחוף את זה פה. כן.
יש לנו גם פאשות. לא מומחה בלייב.
קרה פה טמפו יד רגע עם הכפתור?
בצעת לך.
כן,
אתה הבן אדם הכי גרוע. אין לו חור.
אין לו, יש לו חור פנימי. יש שם עוד אנשים? בוא נראה שנייה את זה. כן, אני בא, רגע, רק בודק את המיקרופון פה, במראה. כזה. אוקיי, לא, כן. פה בחדר ההלבשה... לא, כי זה... כן. תחזיר אותו, אתה רואה איזה כפתור פנימי כזה?
כן. רגע, תפעיל, הבנתי אותך.
זה איפה הגישה אליו? הנה.
בדיוק.
בסדר, הבנתי אותך.
אוי, וואו.
תחזיק את זה. דברים כאלה עושים בשתי ידיים.
כן, חייבים.
פיקס, תביא.
אוקיי, עכשיו זה איפה?
מה? איפה שתרצה, איפה שזה, אין לי
לא
בעיה
מפוחד
שיראו
משנה?
את זה.
לא, איפה שלא יהיה חזק.
קלאסי זה ככה.
שים. שדר.
רגע, לא, קלאסי זה שזה יהיה בחוץ. ככה זה מפריע לך?
לא מפריע בכלל.
פצצה.
מעולה, תודה רבה.
שיהיה בהצלחה.
תנקס. מבחינתך good to go או שצריך לעשות איזה בדיקה?
אני רק שאורי יאשר, אני סגור.
חזרנו מחדר ההלבשה.
אתם מוכנים?
אורי, אתה רוצה להגיד כמה מילים לפני?
לא עכשיו, נכון?
מה?
לא עכשיו.
לא, אני מרוכז פה לאט לעמוס, תגידי כמה מילים ו... לא, אנחנו אולי...
שרוני, כן, אופיר.
תעשה חתיכת שישמע אותך.
חד חד חד.
אוקיי.
רגע, נתקע לי פה משהו.
טוב, שלום לכולם. אתם בסדר?
שומעים? חד חד חד.
טוב, ברוכים הבאים לאלומה, או עוד היום אני מרשה לעצמי לקרוא לנו אלומה. בעצם אנחנו בקרוב גוגל, אז ברוכים הבאים לאלומה או גוגל, או מה שתרצו. אנחנו מעריכים פעם את המיטה, ובתקווה גם את המיטה הבאים. אנחנו מעריכים עוד חודשיים.
כן.
עוד חודשיים אנחנו נארח גם בגוגל קמפוס קפקאטון.
עם שני אורחים בכירים מאוד
כן.
מקפקא.
כן, רק אתון על קפקא, אז אל תפספסו. היום אנחנו נתחיל עם אופיר, ואחרי זה איתמר ידבר.
אולי תגידי, אנחנו מנסים איזשהו קונספט חדש של מיטאפים יותר קצרים. בדרך כלל המיטאפים הם 45 דקות עם איזושהי הפסקה ואחרי זה עוד 45 דקות. אנחנו עושים איזה 30 דקות, אמרנו, לקחנו שני מרצים שהתכנסו ל-30 דקות, איזו הפסקה קצרה באמצע, רק להעביר את המושכות, ועוד איזשהו סשן של עוד חצי שעה. אנחנו רוצים לראות איך זה, אז באמת התגובות שלכם, אם תגידו אם זה נראה לכם יותר מתאים, אנחנו ננסה להמשיך בקו הזה של מיטאפים יותר קצרים ומקומפרסים בערך לשעה. זאת אומרת, חצי שעה הרצאה באמצע רק החלפה, ובהתחלה עוד חצי שעה של מינגלינג כזה. אז אם זה יותר מתאים לכם, תגידו, אנחנו נתכנס לכיוון הזה.
All right. So as requested, I'm going to do it in English, but you feel free to ask Hebrew questions if you want. So good evening, everyone. It's great to be here. This is actually my second time here at Kafka TLV. The previous time, last year, I talked about a pipeline called From Kafka to BigQuery, comparing multiple streaming techniques to pass data downstream. You can YouTube it if you missed it. It was also presented later at Kafka Summit London. And today I'm going to talk about Kafka Streams. So it's a good time to ask you guys by raise of hands, how many of you have hands-on experience with Kafka Streams? All right, so that's about 50-50. So for those of you who didn't raise their hands, that's good, because this is a basic level Kafka Streams talk. And for those of you who do have experience, I think that's also good, because today we're going to talk about a requirement for a system, which is not that easy to implement using old-fashioned tools. And we'll try to implement it with our standard techniques. And let me give you a spoiler, it's going to be a mess. And then we're going to try to build it with stream processing. And it's going to be that simple that we'll do it more or less with 15 lines of code. So I'm Ofir. I work at MyHeritage. By raise of hands, do you know MyHeritage? All right. So for the few who were shy enough to didn't raise their hand, at MyHeritage, we're all about connecting you with your relatives. We help you discover amazing discoveries about your family history and about yourself. And you can do that by building your own family tree. And then you can leave it to us to connect it to millions and billions of family tree profiles from around the world. And you can also reveal your secrets by taking a DNA test and get your genetic secrets. And MyHeritage also sponsoring the leading sponsor of the Eurovision next month. So let's see a short movie about MyHeritage. איפה מכבים אותו? תודה.
Looking for my grandparents.
Now we'll see what happens.
Oh my god.
Oh my god, this is tough.
Carrie is right here.
But my great grandparents right here.
Ah, my grandmother. And as relatives I didn't know existed.
I never met my father. It's just it's all like right here. And I've never gotten really this far.
Okay, so this is MyHeritage. Let's move back to full screen. And let's talk today about this dog, or about a fraud detection system. I would say like a gatekeeper that I think any website needs something similar to it. We're going to try to identify common attack or attack vectors performed by attackers who are trying to do malicious things to your website. And after we identify them, we'll try to react to these attacks in near real time. So first, I want to define what are the requirements for my system. Or first, what are the suspicious activities I'm trying to identify? Of course, you can think of suspicious activities of your own, but these are just a few examples. First of all, any website has some internal page or a utility, a back office utility that can access only from the inside. And if an attacker tries to access it from the outside, even if you have the measures to block this attempt, you only write it down aside and know that such an attempt had happened. Similarity, there are some endpoints who are exposed only to a specific IP range, and you want to know if they were tried to access outside of them. Then we have parameter tampering. Parameter tampering is an attempt to change the parameters that are passed to the servers in many, many ways. They can come as XSS or as SQL injection. And the attacker may try to change the application data, for example, to change product prices or to steal credentials. And this is something that any website, I think, is vulnerable to. Then we have sensitive URL requests. What I call sensitive URL is something special. For example, /admin, /login, /authenticate, URLs that I may have in my system, and maybe I don't even have them, but an attacker is trying whatever he can, trying to find the weakest link. So I want to know an attempt had happened and write it down. And then the last example is account takeover. As it sounds, an attacker can try to take over user credentials in your system. Let's say he had still many emails that can access your system, and he's trying, for example, he can try to access with his IP. He can try to log into the same email address over and over. Of course, you have to be careful about a user just lost his password. Perhaps he'll try the same email from different IPs, which is suspicious. And perhaps he have a set of of emails that he's trying to access from a single IP. And this is something that is very suspicious, of course. And then I'm sure you can think of many other attack vectors that are relevant to your own websites. All right, so now let's try to define the problem. Let's say we know how to identify all these suspicious activities, and we give each and every one of them a score, a penalty. For example, a suspicious URL like /admin, /login, /authenticate is something I want to give a very high penalty, like 100 points. But an access to some other endpoint which is less sensitive, I'll give it 50 points, or an attempt to take over an account by invalid login, I'll also give it 30 points, and so on. So I'll give a score by the severity of each and every action. Then I'll define a time window, let's say 10 minutes. And I want to try to define a threshold, let's say 1,000 points, that if an attacker, a potential IP or user, has passed this threshold in this given time window, I want to mark it as a suspicious, as a malicious IP, and respond accordingly. How can I respond? This is really up to you. I can raise a sensor. I can block the IP, but of course I have to be very careful because IPs are dynamic. But it gives me all the options on the table to react. So I hope the requirement is clear. Feel free to ask if it's not. And now I ask you guys to take a few seconds and think in traditional methods without streaming. You know this is a streaming session. How would you implement it? What would you do? What would you have done? Doesn't have to be a full-blown solution, just an idea.
Cache IPs into Redis and update the score.
All right, cache IPs into Redis and update the score. That's a good option. Working with cache. Anything else? All right, so I'm going to try to propose an option that I would have taken a few years back before I knew otherwise, before I knew better. And I'll call it the classic old-fashioned way of doing things. And this is what we're going to try to do, and we'll see if it gets the work done. All right, so first of all, I've said that I know how to identify those suspicious activities. So first of all, I would like to store all these activities in some database. And of course, in order to do that, to store and fetch these activities later, I would like to write some data access layer or ORM in order to do so. Then I'll run a cron job that runs, let's say, every 10 minutes or every time window that I've defined. And this cron job will periodically process a batch of data. It will take all the activities that happened in the past 10 minutes and try to identify if we have something to respond to. Before summing up those attacks, I would like to filter those irrelevant requests. For example, if there are trusted bots, like Google, for example, which I trust, or let's say internal IPs, I know their IP address, I trust them, so I would like to filter them out. Then I'll take whatever's left, and I'll aggregate these activities in the given time window by user ID. I won't have user ID all the time, so probably I would have to aggregate by client IP. I'll do some penalty calculation service that will sum up all these activities, give a score to each and every one of them, and aggregate. And then all I have to do is decide which user or IPs have passed the threshold. Now last, I'm going to respond to the attack. So what do you say about this approach? Does it have any problems in it? Database, OK. Database is one problem. What's the problem with database? OK, it's not distributed.
Depends which database.
Say again? Cron job. It's not real time, right? So an attacker, which is, let's say, call it mediocre attacker, in 10 minutes, he can probably crash my website completely. So let's see what else. So of course, as you can see, this is a lot of work for a pretty simple requirement. So I'm probably going to end up with a lot of components that I have to develop, a lot of boilerplate code to build those ORM or database access. I have to maintain it, to test it, a lot of moving parts in my system. Then an attacker can sneak between batches. What does this mean? I said I'm working in a prefixed window of 10 minutes. So a smart attacker can do a set of actions in the 9th minute of a window, and he won't pass the threshold because he understood what it is from earlier attempts. I won't identify it, and he'll complete his work in the next window. Let's say he'll do things in the 9th minute and in the 11th minute. And because I'm waking up every 10 minutes and getting all the activities, I won't be able to identify this attack. And of course, as we said earlier, if the attacker is even smarter, he's going to do big things in 10 minutes, steal credentials and so forth. And as you said, this is not a real-time implementation. In 10 minutes, a lot can happen before I had the chance to respond. And also another question relevant here is, does my existing solution scale up to millions or billions of events? Probably not. So let's try something different. And obviously, I gave you a hint earlier. We're going to do it with Kafka Streams or with streaming. And this is the streaming way of real-time detection. This is our attacker. He sits in the coffee place next to his house. And he does all kinds of suspicious activities. Right now, in order to get real time here, I send these activities to Kafka. And over Kafka, I run a stream processor. This stream processor doesn't really have to be Kafka Streams. It can be a lot of other stream processing frameworks. But we'll see later why Kafka Streams is a good choice here. And then, after doing everything in a single bullet here of streaming processor, I'll emit all those IPs I found as malicious to another Kafka topic, and let another application downstream to fetch, to consume this output topic, and react as it wants. All right, so let's see why Kafka Streams is a great solution for this before we see the actual code. So Kafka Streams, for those of you who missed it, it's a streaming application library on top of Apache Kafka. It's just a library. If you're writing Java, you're adding a dependency to your POM file, and you're good to go. You're writing it in simple Java code. It continuously analyzes unbounded data. That is, data is coming in real time and analyzed all the time, and then allows me to react in near real time. As any other stream processor, we can join streams, filter, maintain state, perform aggregation, as we'll do in a moment. About the state management, as some of you perhaps know, Kafka is replicating the state, is keeping the state in memory until a given threshold. Then it can store it with RocksDB embedded in your process, in your machine. And if this machine crashes, it's replicated to another internal Kafka topic that when you raise your instance all over again, you can go back to your own state. As I said, we're going to run a simple Java application here. We'll see the code in a moment. And then by leveraging Kafka Stream semantics, we can achieve scaling pretty easily, as we're bounded to the number of the Kafka partitions. This means that we can raise instances of our Java application very easily up to the number of input topic Kafka partitions. And then we can scale. We can also raise the amount of partitions to scale even further. And Kafka Streams will automatically know how to split the data between all those instances. Each instance will take one partition or more according to the number I have. So scaling becomes really easy. Then also fault tolerant is, as you know it with Kafka semantics. It means that when one instance crashes, all the data is replicated automatically to another living instance. And when this instance that was crashed comes back to life, it takes a set of data from the other instances.
So it's no auto-healing?
Say again?
No auto-healing.
Auto-healing of what?
So you need to take the node up to continue to work properly.
No, I don't need to do anything, actually. That when one instance crashes, all its data is replicated automatically to the other instances I have in my system. And of course, I can raise more instances. I can decrease instances. The balancing of the data is done automatically.
Because the Kafka itself, it's not auto-healing.
Right. I see. Any more questions? OK, so this is a good chance to remind you guys of windowing. And this is actually quite general to all Kafka, to all streaming applications, not only Kafka Streams. So let's take first the simplest window that we have, which is on the left, the fixed window. the fixed window is defined only by its length. For example, in this example, we have 1 hour length, so we get a window from 8 to 9, and then the next window will be 9 to 10. The problem with this window is that, as I said earlier, an attacker can sneak between batches. He can do a set of activities here, just before the end of a window, and another set here, and I won't be able to identify it. But of course, the pro here is the simplicity of the fixed window. So if you want to solve this problem of sneaking between batches, we'll go to sliding window. A sliding window is defined by the length of it, 1 hour in this case, and another parameter called the hopping time. In this case, it's 1 minute. So we have the first window 8 to 9, and then 8:01 to 9:01, and 8:02 to 9:02, and so on. So this means that we won't miss anything, like we missed in the fixed window. But on the other side, we have duplicate data here coming for different windows. So we'll have to know how to handle it later, maybe dedupe it, maybe deal with it downstream. According to your output downstream system, you can decide if you want to deal with the duplication downstream or within your Kafka Streams application. And then the third and last window is session window. Session window is less relevant to this talk, but it's important that you'll know what it is. Session window is defined by an inactivity timeout of a user. For example, it's defined by 30-minute inactivity time, and when a specific user or a key here is inactive for 30 minutes, the window is closed and another window opens. So as you can see, this is the only type of window where the windows are not identical for each and every key. So you can see here, this user or this key has 2 windows right here, and the second key has window in a total different time frame. So this is session window. All right, so we got to the code. And before we'll dive into the code, I want you to take a look that this is my entire code, and it's run over the public static void main right here. Why? Because we just can. The deployment is really easy with Kafka Streams. You don't need any special deployment mechanisms. You don't need Yarn, for example, like other streaming application. You just run your Java application in any given deployment mechanism, for example, in a Docker container. You build it, you build the image, you run the container, and you're good to go. So let's see what we have inside. All right, so in the first 2 lines, what I'm doing here is telling Kafka Streams, hey, take the topic called input topic, and I'm defining him as the messages has a key, which is a string, and a record, which is defined by this arrow, which you don't see here. It's an object, more or less. And then I'm telling Kafka Streams, please do the filtering, which I talked about earlier. Take all those IPs I trust, for example, the Google bots or the internal tools, which I want to take out of this fraud detection system. And this is a simple predicate, a simple functional interface in Java, just a function that returns Boolean, and I'm good to go. Then the grouping is that simple. Group by key. My key here in this topic is client IP, but it doesn't have to be client IP. I can also group by the actual value of the message, but this is the simplest way to go. Now I'm defining the window. We talked about earlier about the middle window in the previous slide, the hopping window. So I'm defining a window here of 1 hour long and hopping by a minute. So this means I have those windows we saw earlier, 8 till 9, 8:01 till 9:01. So I'm holding an hour in my hand all the time. Then the aggregation, it's actually much more simple than what you see here. Just an addition, just an accumulation of the data. Each and every value, each and every suspicious activities, these are my values here. It has a penalty, it has a score, for example, 50 points. So what I want to do is calc the score, for example, 50, and then add it, accumulate it to this IP, which I grouped by earlier. Then I'm going to do the filtering. Up to now, I have those IP grouped by and accumulating by score. And now I want to take only those who passed my predefined threshold, only those who passed, for example, 1,000 points in a given time window. So everyone else goes out. And all these that are still in the pipeline are written to another output topic for me to respond, decoupled completely from this pipeline. And up next, I'm just telling Kafka Streams, take the builder that they defined above, take a few configuration lines in the code itself, and start running. Any questions about the code so far?
Can you calculate on key in streams? Because each time I want to construct another key, not the,
no, you
not
have
the
a
key of the Kafka.
Right, so you have a single partition key. In my case, it's client IP. And if I understand the question correctly, you're asking if I can do the aggregation by something in the value. For example, an element in the value. Let's say my key is something totally different, and I want to do my grouping by an element in the value. That is very, very easy. Just change the group by key to another group by and tell it which item in the value you want to group by. And it will create another intermediate topic inside, which is aggregated by the value you've specified. Yes?
If the score has the threshold between 850 to 9?
Between 850 to 950, because I have a 1 hour. I'll repeat the question. Please continue.
All the event in this 10 minutes was enough to pass the threshold.
OK. Right.
For all these windows.
Right,
so
OK.
you will ping a lot of alerts.
Correct. So the question was about duplications. When I'm working with hopping windows, I'm holding in my hand windows that are overlapping between them. So probably if I'll find someone who passes the threshold in a given 10 minutes, it will, as I have a 1 hour long window, it will also pass the threshold in other windows. So here's my options here to perform dedupe. I can either do it downstream. Let's say I write this to a Kafka topic, and then I take this Kafka topic, for example, to another system in a different layer. And this system, let's call it a data warehouse or a database. I can do something like an upsert, which is insert or update in a given time frame. Then I can handle dedupe there. Also, another option is to handle the dedupe in Kafka Streams itself by adding another couple of lines here that grouping again by the actual IP. And if I have duplication, I have the multiple IPs here. And then doing reduce by the latest message that was received. And then I will be able to perform the dedupe here in Kafka Stream.
To implement the dedupe, you get it out from the topic and get it inside the GAN? Or
Right. So in this topology, this entire code is called the topology in Kafka Streams. So this topology is creating many intermediate topics. So if I perform another grouping at the end to perform the dedupe, then another intermediate topic will be created. And you won't see it because it's like hidden. But if you browse to your Kafka broker and receive all topics, you'll see it easily. And this intermediate topic, of course, will be created by another attempt of grouping.
But I don't define the topic.
No, you can define the topic name, but let Kafka Streams do it for you. It's better. They try to make it as transparent as possible because you shouldn't, unless you're doing debugs or so forth, you shouldn't consume this topic directly. But you can.
With which replication factor the internal topics are working?
The replication factor is really up to you. It doesn't really matter. It's another concern for you in order to to have your availability and whatever you need in order to have the replication factor, for example, of 3 or 5 or whatever it is that you want.
It's configuration.
It's configuration in Kafka. It doesn't really even relate it to Kafka Streams. It's configuration of your broker.
No, but you can decide the replication per topic. So I don't know what the default replication for internal topic.
But what do you care what's the replication factor when you're the developer who writes this simple pipeline? Let's take it as given. Of course, you have to know that you have a replication data and a replication factor and your data is always available. But this is really, it's really not that related to this Streams application, because if you have the replication, then you have it also behind the scenes here. You also have to remember that in Kafka Streams you get extra fault tolerance mechanisms as we described earlier. Crashes that are passing the data, balancing automatically to other streams instances. Yes?
Assuming you fire an alert or block the
Right.
user, when do you take it off?
Okay, so this is a good question, but actually it really depends on the implementation that you decide. The question was when I define a sensor or block a suspicious user or IP, when do I turn the sensor or this blocking off? So if I'm doing a sensor, it's really, you can decide if it can wake the relevant PagerDuty person or DevOps or whoever in your company is responsible or the guy that developed this application. And this is really up to him to see what is this attack, whether he identifies it, maybe it's a bug, or maybe it's a real attack that has to be addressed immediately. And if you're blocking, you have to be quite careful because you're blocking IPs. So IPs are dynamic, so you want to block these IPs only for a few hours, maybe even less, in order just to stop whatever it is that's taking place right now, and then release and allow other users to take these IPs. Yes?
In which environment you are running? Is on brokers to achieve some data quality?
All right, so the question was which environment runs the pipeline? And the answer is no, I'm not running Kafka Streams on my brokers. I'm running it on other servers which are running, let's say if I do my deployment in Docker containers, which is obviously not a must, then I have these microservices which I run. I can also run other microservices which are not Kafka Streams on the same server. I would probably like to split my instances between multiple nodes, because if one node completely crashes and it has all my Kafka Streams instances, then I'm lost. But if I split them and have at least 2 or 3 nodes that have Kafka Streams instances, then I'm good and I can suffer faults. Yes, please.
If I have a topic with a very high rate, for example, location event, something that billions of devices can send simultaneously. My question is, how do you refer this via the topology that you use? How do you scale out? What is the technique? And maybe if Kafka Stream is a good choice, or maybe Spark Streaming, or maybe some other framework for this kind of high rate.
All right, so the question was about scaling and scaling out. Let's take it, for example, IoT events, which are coming in scale, which is maybe even more than millions and billions. It's really a question of how well you define your resources. For example, it's a question of your Kafka Streams, the input topics of this application, how many partitions it has. So your scaling will have to raise the amount of input topic partitions. And then after you do that, you will want to raise your application instances up to the number of the topic partitions you've set. For example, let's say you worked on 5 and 5, then you increase the topics to, I don't know, the partitions in your input topic to, let's say, 50, and then you can raise as many as 50 instances. If you raise 50, then one instance of Kafka Streams will take one partition. If you raise less, they will know how to split the data.
Can you add instances online? Or
You can add instances. So let's split between adding partitions and adding instances. Adding instances is just as a matter of how you deploy your microservice. You can obviously do it in real time. Even you can do it by, say, you use Mesos or you use Kubernetes. You can raise the amount of partitions as you go, the amount of instances as you go. Okay, so let's do one last question, and then there will be one slide for questions later. Yes?
The second half of the question. I already have a very big topic because location event is something very busy. So
all right, so let's...
Hundreds of partitions.
Okay, so that's no problem.
The opposite. If I raise 1 or 2 instances of the K-stream, how will we balance all the partitions?
If you have, for example, 200 partitions, you won't raise 2 instances of Kafka Streams. You'll raise, I don't know, 50 or 100. It depends on your resources. But let's continue. If you want to take it later, we'll take it later after the talk. All right, so let's do some summary of where we stand after implementing this application. And if you remember, we had a previous suggestion for implementation, and I would argue that the latter implementation is much more simple. I have one application to maintain. Of course, I have to know what I'm doing, but it's more simple than the previous, in my opinion at least. Then we have correctness. Today, streaming applications, not only Kafka Streams, can handle late data, for example, data that's coming out of the expected window by using measurements like event time and so on. So you can deal with correctness very good of your application. And obviously, you can handle this problem we talked earlier about sneaking between batches, which is solved now. Then we have real time. There's no more an attacker that will perform actions in a few minutes before I'll close my window. I identify each and every activity in real time and respond in real time. And last, the scale. We talked about it a lot. I can easily scale to millions and billions of events and support whatever is needed from my system. That's all I have for today. Thank you very much, guys. Is there time for more questions?
No.
OK, so thanks a lot. מצוין. סוף סוף. עשית פה משהו קשוח. החבאת אותו. כן? אתה up next?
אתה?
הצלחה? איך זה השם?
לא, סתם, אני כבר רואה, אתה יודע, דקה שזה, כולם...
לא, לא משם.
אבל מכיר.
מכיר.
בגדול, אתה מוריד את הז'קט?
לא, אני אשאר איתו.
מה שבא לך, אם אתה לא מוריד, אז אתה יכול לשים את זה כזה ככה.
זה אתה אומר? לא, אני אשים את זה דווקא על החולצה, במקרה שאם אני אוריד. שלא נעשה לך פדיחות.
רגע, תן לי רגע.
מדהים.
בגדול...
שים על זה.
טוב. ככה זה מעולה.
מדהים.
רק בוא נעלים לך את זה. זה יפה לך.
תאמין לי, אתה אין עליך.
תדחוף את זה פנימה. רגע, תן קצת שחור, בדיוק.
מדהים.
מה שכן, לא בא לי שיראו את זה.
את מה? את זה? שטויות. אני אשים את זה תמיד על זה. אה?
אל תעמוד שהמקרן עליך.
אוקיי.
תעמוד בצל.
אני כל כך הרבה מקום פה, אבל...
המצלמה רואה אותך.
עכשיו אני בסדר?
אתה מסתובב?
לא, לא, אין צורך. מעולה.
בדיוק בבית שלכם.
בסדר?
אנחנו ממשיכים ישר בשיחה השנייה.
Hi everyone. How many of you have heard of Presto? Good. Surprising. So my name is Itamar. We are going to talk today about executing SQL queries on Kafka. And we'll be doing that using a product that's called Presto. I'll explain all about it. It might be a bit different than what you used to hear about in this user group, in this meetup, but hopefully it will be interesting enough. My name is Itamar. I'm the CTO and founder of a company called BigData Boutique. We are representing a couple of big data vendors here in Israel. One of them is Elastic, one of them is also Starburst, which are behind Presto, which is the product that I will be talking about today, all of which are open source. But we do integrations, we do projects, we do consulting and support around those technologies. And we do quite a lot we build quite a lot of data lakes, data warehouses, and those buzzwords, but we do it and we help companies succeed with managing their data and their infrastructure and software accessing that data. Presto is, for those of you who haven't heard of the name before, Presto is an open source product that was built by Facebook quite a few years ago. I think it's about 6 or 7 years now. They had some issues, some performance issues, running SQL queries on HDFS, right? So on big data, maybe stored properly, but they had some issues running interactive SQLs or interactive queries on top of that data. They tried using Hive. Hive wasn't good enough, so they went and built Presto, which is an execution engine very similar to Hive, which is basically what is done to be a replacement of, and also those of you who know Spark. So it is more of an execution engine rather than a database on its own. It is not a database. It is a computation engine, which is also something that we know by the acronyms of MPP, right? So massively parallel processing. You give it your data, or you put it somewhere close to your data, and it is able to just execute queries very efficiently on top of that data. With Presto, queries are very, very cost efficient. So you don't have to have huge clusters to be able to run timely queries. You just can execute your queries, and they will return in an interactive manner. Obviously, a lot of work has to go to make it happen. So partitioning and all of those things, but it works. If you do it correctly, it works. And this is why Presto really is really something that people start implementing and integrating in their systems lately. There is an enterprise version. It's supported by a company that's called Presto, which is basically a company that was established by Facebook veterans. The people who built Presto in Facebook basically went in and established their own company. So just to give you an idea what Presto is. So Presto was designed initially to query data, cold data, on cold storage, which is HDFS, S3, and such protocols and storage systems. And it is where it really excels. So most people who use Presto to query cold data, execute SQL queries on cold data, mostly on HDFS and S3. But Presto on its own, it's a computation engine. It doesn't really tie into any underlying system. And this is why it is also able to query a lot of other databases or data sources, or however you will. So for example, obviously, it is able to delegate some SQL statements, some SQL queries to SQL databases, right? So you can put SQL databases and put Presto on top of that, and it will be able to execute SQL queries on SQL databases. No surprise here. But it is also able to query NoSQL databases, right? So databases, data stores that are not SQL by nature. So Cassandra, Redis, MongoDB, recently also Elasticsearch joined that list. So databases or data stores that are not SQL by nature, they are not relational, and maybe they don't even understand SQL as a language, as a query language, they are still, you can still run Presto on top of that, and those queries are going to run on top of that data. Maybe the most surprising bit was the addition of Kafka as a data source. So Kafka is a queue system, or to be rather more exact, a commit log that you can store data in and query or go through the data. And it is basically something that you can think of as a vertical, right? So messages come in, and then you just can read them and do things on top of them. What Presto is able to do, and we'll talk about this in just a minute, it can basically take that vertical thing and make it horizontal. So each message is going to be a row, all right, in a database, and we'll talk about this in just a few minutes. And Presto is able to do all of that using what we call connectors. So Presto comes bundled with quite a few connectors, and those connectors, each connector can connect you to some data store. Each data store has its own, obviously, capabilities and abilities. And those connectors are what basically are translating the SQL or the queries that you are going to run and pushing them down the stream into the underlying storages. Presto does behave like a database in the respect that it exposes a JDBC protocol that you can query from everywhere. So you can query from using Redash or Superset. How many of you have heard of Redash? Amazing product. Israeli guy, Arik, amazing product. You should definitely go and check it out. Superset is pretty much like Redash, but under the Apache umbrella. So you can use those sort of IDEs or dashboarding systems on top of Presto. You can use commercial ones, so Tableau, Power BI, all of those products, they also speak JDBC, so no reason why you cannot do that. You can use notebooks, like Jupyter notebooks, those kind of mechanisms to query data stores, query execution engines as well. So you can use Jupyter to query Presto as well. And obviously, IDEs like DataGrip, MySQL Workbench, every software system that is able to speak JDBC, you can use to query Presto. And this is where Presto becomes a very central point, really a focal point where you can query any sort of data from pretty much everywhere. And the good thing about Presto is that all of those data sources can be joined together in a single SQL statement. So each of those data sources is going to be exposed to you as a catalog or as a database that you can query. And if you have multiple databases defined in your Presto deployment, you can basically just execute a single query and do joins across data sources. And the entire computation is going to be basically done and executed in Presto. And this is the beauty of Presto. Presto is being used worldwide. It has a very, very strong adoption curve. It's obviously being used by Facebook probably the most because Facebook put so much effort in building it. I think this is like data that I took from the net. And Facebook, back then at least, about a year ago, said they have thousands of nodes in multiple clusters, Presto clusters obviously, running on petabytes, hundreds of petabytes of data, and have many, many concurrent queries basically being executed by their analysts. But also, if you build that thing correctly, you can also use Presto to support queries coming from your application. So Facebook, Netflix, Twitter, Uber, so many such companies, and also other companies which are maybe smaller but have demanding needs as well. They also use it and use it very successfully, and Presto really, really shines, and especially lately. So the architecture of Presto really resembles what you probably know from other systems, like, for example, Spark. We have a single coordinator. There is some work to put more coordinators within a single Presto cluster, but currently a single coordinator which accepts the query through the JDBC driver, the CLI of Presto, and takes that query, analyzes it, creates a query plan, and then executes that plan using the workers. The graph here shows HDFS, but obviously you can have pretty much any data source that Presto supports and have the workers talk to it. So accessing Presto, like I said, to execute queries, you can use the JDBC connector, the JDBC driver, or use the CLI directly. And because you have the JDBC driver, you can pretty much access Presto from everywhere. And there is also a very nice UI to Presto that shows you what's going on now, and we'll see that in action. But basically, when you run real workloads on Presto, you'll see something like that, right? How many data you are reading, you are querying on, how many concurrent queries, how many users, how many failures, how much data in gigabytes or terabytes you're reading, and so on and so forth. So getting to the Kafka connector. Again, like I said, in Kafka, it is a commit log, or rather maybe a queue system that has messages coming in one after another, and this is basically what it is. You can go back and forth on a Kafka queue or a Kafka topic to just read that data, which is cool. What Presto is able to do with the connector, it can take that queue and make it horizontal and make every row, every message like a row. We'll talk about how you understand what fields you have in that message in just a second. And then you basically get to a point where each topic is being represented as a table to Presto, and then each table has columns which you define based on your schema. And then when you query, you're basically querying a table and rows with columns, just like you would do for SQL. So decoding a message, when you have a message, that message can be just bytes, right? But you will usually have some sort of a schema. So out of the box, Presto and the Kafka connector that Presto comes with supports JSON, Avro, and also CSV and row decoders, meaning if your data in Kafka is using one of those formats, so it's either CSV, JSON, Avro with the schema for each message, not the schemaless Avro, or it's just raw data, which is basically just a primitive, which might be not something you would do, then Presto, using the Kafka connector, can just transform that natively into a table, right? If it uses something else and you need your own serde, this is something that is quite easy to do, but it's not something that's very easy to do out of the box, right? You cannot just install and configure. You would have to do a bit more work, but out of the box, JSON, CSV, and Avro are fully supported. So just going back 2 steps. Presto, the use cases for Presto, like I said, is querying mostly cold data. So you have HDFS, you have petabytes or maybe terabytes of data, and you want to execute that very fast. So SQL on anything, that's the term that they give it in Presto. And you can use Presto to query cold data and also other data sources and even join them together. You would usually use that for cost-effective querying. And if you want that more interactive, you'd probably add a bit more hardware. But then you can also put analysts on top of that and make queries on cold data very efficient. For the Kafka use case, as it turns out, Presto is also very efficient or very easy to use for ETL processes. You can basically, if you build your thing right, you can take data from Kafka and you just use an ETL within Kafka, right, for another topic, or maybe to cold storage. So you can take messages in Kafka in JSON format, let's say, and then transform them into Parquet format files on HDFS. And you can all do that with just a simple insert into, select from in SQL using Presto, which is kind of nice and kind of neat. But obviously, you can use that for querying Kafka. If you have Kafka data coming in real time, you can just query Kafka and get results. And then maybe, I'm not sure whether this meetup likes the concept of Lambda architecture, but this is a nice way of implementing that. You can submit a single query to join basically results both on real-time data on Kafka and from cold storage, which is pretty much what Lambda architecture is all about. And also, obviously, allow your analysts to just query data that is in Kafka. And again, I'm assuming live data, but obviously Kafka can be used with long retention periods. So we're a bit short on time, so I'll just skip through that very quickly. Presto SQL is just ANSI SQL, it's just standard SQL, but it has a lot of additions like windowing functions, aggregate functions, geospatial queries. So you can actually use geospatial operators on WKT shapes if you have them defined in your data. There is some other enhancements like Lambda functions within your SQL queries, using JSON operators to extract data from JSON columns, if you will, or just your data. Other nonsense like, I don't know, retrieving back colors or extracting URL parts and doing other extractions and maybe enrichments kind of operators, which is kind of cool. How much time do I have left? 5 minutes. So I'll have a quick demo, and then I have a gotcha slide, which I would really want to show you guys. So this is the Presto UI, like you've seen it. This is a more recent version of it. Currently, my cluster is idle. I'm running it locally on my laptop. And then you can see, but I also have Kafka running. I can open Kafka Manager and show that to you. but I also have, okay, this is better. And I also have data grip, which is just a SQL client, SQL IDE that I can now execute, run on Kafka. This is a bit small over here, but you can see I have many connections to many databases, just 3. And my Presto local database, if you can see it, it exposes several databases and several schemas, and each of it is different. So one of them is Kafka. And you can see that in Kafka, I have a TPCH schema, which is just demo data, and I have many tables in it. And then I have other databases available to me from within that database definition, and each of them is a different connector being used from my Presto cluster. So I can have just HDFS and S3 and all of those. So from within Kafka, from the Kafka databases, Presto sees it, I can just execute queries. So I'm telling it to use the Kafka, database, then the TPCH schema. Show tables will return the tables that I have available to me, basically what you see here. I can just use standard SQL on that. So describe customer. Customer is just a topic in Kafka. But as you can see here, I can actually see the records, the columns within it as properties. There is some internal fields which describe the message key and which partition it came from, etc. And then I can just execute standard SQL statements. So select star, which return data, do aggregate functions. And here you can see I'm also using some JSON operators. So I'm accessing a field that's called message, which is the raw JSON message from the topic. And what I'm doing here, I'm basically extracting a scalar and then summing it up. I also have that specific field as its own field already extracted by Presto, so I can actually do this directly on that field. And I can do group by market segment, etc., etc. So I have the link for the tutorial you can follow that will show you just that. Okay, so the playground where you can actually run this as Docker Compose, you have that here in this Git, and you can follow a Presto official tutorial around that in this link here. And the idea is basically that you can take any data and transform it into a table using Presto in that respect. But I did do a hack here that I couldn't show you because we are a bit short in time. But basically, I had to tell Presto how to translate the JSON into what is the schema behind the JSON, right? So if it was Avro, it was already defined within the message. But for a JSON document, I had to actually put a description document that translated the JSON into a schema. So it's no big deal. You'll have that in the link in the tutorial, but it's something you have to do for JSONs. And also there's more gotchas. So for example, if you're executing queries on live topics, and that live topic, by live topic I mean new data is being added and maybe old data is being TTL'd, so removed by Kafka, you should probably expect results to change between queries. And also, if you're doing self-join on the same table, that could obviously also lead to some unexpected results, right? So because a row can be there at the first stage of the query, but not there at the second stage, so take that into account. And if you're joining across connectors, taking under consideration that some connectors are going to be slower than others. So for example, the SQL connectors, the connectors that are going to execute queries against old or good old SQL server, MySQL, all of those connectors are single-threaded, so it's going to run a bit slower. It's not like connectors that are against S3 or HDFS and Kafka that can also run multi-threaded. So let's have 2 minutes of questions, and if you have any questions, I'll be happy to take them. And you can freely reach me out on Twitter or whatever. Yeah.
Just repeat the question.
Yeah.
You are doing a joins. Can you index the sources after you put the information, the data?
Index where?
Index on the Presto when to accelerate the joins.
So Presto doesn't have any indexing whatsoever. It's all ad hoc. There are some concepts where you can have a very heavy query on Presto. So the question was, can you have indexes? Does Presto have indexes? Can you use them to speed up things? Presto doesn't have any concept of indexes. You can issue a long query, long-running query, and take the results that it returned and put them in a temporary table somewhere. So you can put them in HDFS, you can put them in SQL, there is a memory connector that you can put temporary tables in. So there are ways of creating materialized views, if you will.
In the last session, you talked about windowing.
Mm-hmm.
Take a part of window, take a part of the time,
Mm-hmm.
watch the stream.
Mm-hmm.
How do you do it in Presto?
There is, I think I put the link for that. There is, I didn't. So in the documentation, go and look for windowing functions, windowing operators. It's a long document, and you have all the possibilities there. It's the over operator. You can basically create a.
Like in a regular SQL
Yeah.
windowing function.
Yes, I think it has some unique enhancements around that, but yes, you have over time. Yeah. Yeah.
You have compared Spark to this, so can you elaborate a little bit about some major differences? And
Yes.
when should I prefer when I want to pick up my new technology? When you think it will be better, from your experience, to choose Spark, and when will be better to choose this?
So the question is, when would you pick Spark and when would you pick Presto on over Spark? So Spark is kind of a de facto standard for computational jobs. The design behind Spark is offline. So you submit a job, it will return sometime. And Hive is basically built in a way on using Spark on top of Spark in some way, right? It also produces MapReduce jobs or RDDs or data frames. And Presto it was built for faster execution. By default, Presto has some concept of killing a query if it runs for too long. So it wasn't designed for offline jobs, offline batches. It was designed for real-time or interactive queries. So this is probably the most major difference. And the reason why it was designed behind that is because the algorithms underneath it are designed for executing the query properly, doing push downs as much as possible, using splits correctly. So a lot of logic behind how can we run queries faster and closer to the data.
Spark also have some Spark streaming, so streaming also supported by Spark. In this case, you have the receivers and you have other internal support for more faster queries.
So it's not faster queries. Spark streaming is just doing the computation on smaller batches. Yes. Presto is not a streaming technology. It supports windowing functions, but it's not streaming. It's more comparable to Spark rather than Spark streaming.
Database or
it's not a database. It's an execution engine.
Database or it's a batch.
Presto is a computational engine on top of BigData. It's not a database. Right. Last question, because I see people are packing over there. Yeah.
How it perform fast without data locality?
So it push downs. The secret is if you design your data properly, Presto will be able to basically tell the underlying storage what hacks it can use to do the aggregations and filtering and whatever as close to the data as possible. So that is mostly the difference.
In this case, Kafka.
So Kafka, I'm not sure there is a push down employed on it currently. I'm not sure if there is a way of doing push down with Kafka, but if there will be a way, it can be easily implemented in Presto. Push downs are mostly helpful with cold data in that case. Right. Thank you very much, guys. Feel free to reach me out.